There are hundreds of millions of streetlights in the world. Now, think of a smart controller on each. Add to that the number of sensors installed on some streetlights and those installed in waste bins, traffic lights, parking spots. Oh, and let's not forget about smartphones, computers, Alexas. That's millions of devices in cities, all needing an individual internet protocol IP address to communicate with each other, as well as send data and receive commands. IP addresses are like the name each device gets to be able to identify itself to others on a network or the internet. Today, the internet mostly runs on the 4th version, so IPv4. But IPv4 can only support some 4.3 billion addresses, and we've outgrown that. To continue to work with IPv4 despite IP address exhaustion, engineers have for decades relied on tricky workarounds like network address translators or NATs, which allow many devices on a private network to share one public IP address. This reduces the need for numbers. But issues have arisen, especially with management and security of these NATs. This is where IPv4's successor, IPv6, comes to play. IPv6 was created with scalability and the future of the internet and digitalization in mind. It offers trillions of addresses, enough for every grain of sand on Earth to have its own network. This means every device in the world, from a smart meter to a smart irrigation sensor, can have its own globally routable IP address, its own ID card. Because each device can identify itself in a unique manner, the latest IP version allows the development of public open standard networks so cities can avoid proprietary lock-ins and can work with many different vendors, allowing their devices to communicate with agreed protocols and data models. This brings us to what could be the golden goose of IPv6 when discussing smart city and utility projects: 6LoWPAN, IPv6 over low-power wireless personal area networks. This protocol allows low-power sensors to connect to IPv6 networks directly, integrate with cloud platforms, and form mesh networks for devices to communicate with each other, to create advanced automated scenarios, and extend network coverage in the city.
It's business continuity, right? And at the same time, there are new functionalities. It's 6LoWPAN, because before we only had proprietary protocols, right, for mesh networks. But we need standards to get interoperability at the internet level, right? And the point is that there are a number of technologies like segmentation, SRv6, they call that. That is a standard that allows to define network as code infrastructures. And that is something that you can only do with IPv6. In IoT scenarios, because they are large networks, they will need this kind of technologies as well.
Mesh networks allow nodes to talk to each other, so they can give each other the data, relaying it until it arrives at the final destination. This means scaling is easier, faster, and cheaper, because not all nodes need to be in range of a central hub. So when a project needs to grow, devices are just added and they automatically find the best route for data. Some countries like the US, France, or India are strongly encouraging and pushing for IPv6 adoption within government networks and public services to support the deployment of IoT. Madrid is testing 6LoWPAN in its smart digital city strategy. They're testing it along with other communication systems because it's not a competition. Teamwork makes the dream work. The city, along with the IoT MADLab, are testing to see where NB-IoT, 5G, LoRaWAN and 6LoWPAN work best to then adapt to each use case. They've created urban intelligence spaces across the city to test and design an interoperability model for each service.
For instance, we have a long range in some parks in Madrid, Casa de Campo. We will deploy another mesh. For instance, LoRa could be a good option, and we can decide in LoRa, for instance, but with IPv6. But 5G in some places, but narrowband IoT in other places.
We're using 6LoWPAN for the networks of devices that are, let's say, fixed. And we're using 6LoWPAN combined with 5G for all those applications in which we have some movement.
Moving to IPv6 is no longer a question of if, but when. As IPv4 addresses continue to run out, holding onto legacy systems can slow progress and make things harder. Some are delaying the switch because of incompatible platforms, old gateways, or budget concerns, but it's going to happen. For me, the more seamless ways to connect systems and scale projects, the better. When municipalities can deploy projects faster, easier, and cheaper, they can do more with less, which means more sensors, more projects, and therefore a more efficient city.